Okay, hey guys, the whole of Pure 2 in 26 minutes. Good luck for tomorrow. Okay, so chapter 1 we know is algebraic methods, and that includes, if you've watched my previous videos, you know what I mean by I'm a silly Billy. It's when we have the division, okay? Now, a few fun facts. If it says that x minus 3 is a factor, what does that mean? That means that when you substitute in f of 3, you're going to get 0. Okay, if they say that when the expression x plus 4 is divided, you have a remainder of 4. No, let's change that number. Let's say 5. That means when you substitute in minus 4, it's going to equal 5, okay? And normally there'll be some form of simultaneous equations rearranging to get that. This should be nice and easy. Also as well, if the highest degree, and when I mean by degree, I mean like the highest power, let's say we have x squared plus x. And on the denominator, we have x squared, This means that the fraction is, the powers on the numerator and denominator are the same. If the numerator's power is bigger or the same, then this is going to be a top-heavy fraction, okay? So make sure you know this is always greater than or equal to 1, essentially. And I think that's about it for these types of questions. Just, it's about manipulation, double check the facts. I've seen a different way that some people do it like this. However it works for you, that is fine. Okay, proof, really important. Whenever we look at proof, remember, if it says something about prove it's positive, what do we know? Square numbers are always positive, okay? Maybe you have to complete the square, okay? Have a look at that. If it says prove for all numbers, remember to prove for even and odd, okay? And even is 2n, odd is 2n plus 1 or 2n minus 1, etc. Always write down everything, okay? And then make sure you put therefore proved at the end, or a nice sentence. The last thing as well about proof is sometimes it will ask you for a counter example. It literally means find an example where it doesn't work. For example, n plus 2 is always even, okay? Well, if n is 3, 3 plus 2 is 5, which is odd. That is a counter example. Literally just substitute in a number. Okay, one of my favourite chapters now, coordinate geometry, okay? We know that a circle, we have x minus a squared plus x minus b, y minus b squared equals r squared. Okay, so our centre is AB and our radius is, the square root of this number at the end, okay? With these types of questions, I would always suggest drawing the circle. Now, lately, I've seen them use circle theorems within these questions, okay? So you've got to scrub up on your knowledge of circle theorems. So, for example, if you see that they've drawn a triangle here, okay, because the longest side goes through the diameter, what do you know? You know this is 90 degrees. Okay, so you know that this gradient is going to be the negative reciprocal of this gradient and vice versa. Remember when it talks about having a tangent to a circle, so if it talks about having a tangent to a circle, this is a tangent to a circle. This blue line is a tangent to the circle. This is going to have, whatever the gradient of the radius is, this is essentially like a gradient of a normal. It's the negative reciprocal, because we know that a radius and a tangent meet at 90 degrees. What else? Oh, yeah, sometimes when they do the perpendicular bisector of a chord, remember again, this is going to be the midpoint of these two coordinates, okay? And then the gradients are going to be negative. So just watch out for that. Something that I haven't seen in a while, but you never know, might be your lucky day, it might come up. Let's say you've got two chords and it asks you to find the center. You have to find the center. Well, fun fact, the equations of the line of the perpendicular bisectors of each chord, so this equation and this equation will always go through the center. So if you can find the equation of this green line and solve it with the equation of this blue line, you will find the equation of the centre of a circle. Now, I haven't seen a question like this in a while. This is definitely something, just look at it. It's all about manipulation, but when in doubt, draw it out, okay? And there will always be a way. With these types of questions, sometimes, the rules are kind of, you're either looking at the lengths of lines or you're looking at the gradients, okay? Just be sensible and smart. Okay, my favourite chapter, exponentials and logs. So, with the exponentials and logs. Okay, first of all, log laws. We should all know that log to the base, same base, and y, what does that equal? We know when we add, this is multiply, and the other way round. So I'm going to do this one the other way around. When I do x over y, this is the same as log to the x minus log to the y. What else do we know? We know that a to the log of x is the same as log x to the power of a. And we know log to the base a of a, what does that equal? That in fact does equal 1. Log to the base a of 1 equals 0. Remember these facts, because sometimes, for example, let's say you have an equation to solve and they put a 4 there and you're like, oh my god, I need everything logs. Well, actually, 4 is the same as saying 4 lots of log a to the base a, because log to the base a of a is 1. Do you understand that? So it's all about, again, it's just manipulation and knowing the laws. Another law that we have here. So also make sure you always remember this law. People forget this, okay? This isn't a law, but this is how we can change the law. So a to the power of b equals c. What does that mean? That means log to the base a of c equals b. And remember, they are interchangeable. Okay, always remember that when solving. What I see a lot of people do in mistakes, let's say they say solve x minus 2 equals blah de blah, right? And you have loads of things. You end up with a quadratic equation and you get two values for x. You get x equals 4 and you get x equals 1. Now remember, if we were to put these back into the original equation it asked us to solve, 4 minus 2 is 2. It's a positive. We can log a positive. When we look at when x equals 1, 1 minus 2 is minus 1. We would reject this answer, okay? And let's make that really clear. We are rejecting that answer. Some laws that we forget because we do use our calculators, but just so you know, if you want to change the base, now with a lot of the calculators we use, we don't need to change the base because we can add our base. However, if you wanted to do this, whatever base you wanted to do, okay, b for example, whatever the base is, remember that goes in the denominator and then what you're left with goes on the numerator. And lastly as well, this is also a law. Log to the base a of b is the same as 1 over log to the base b of a. So if you wanted to switch them, you can, okay? That is something I don't see come up often. However, bear that in mind. Then, exponentials. They love a hidden quadratic in an exponential, This is one of my favourite ones. I love these types of questions where we have, for example, we will have 3 lots of 2x plus 1 minus 15 lots of 3x plus 44 equals 0. Okay? Well, what does this even mean? First of all, we need everything in the terms of 3x. So with this one, 3 to the 2x plus 1, actually, this is 3 to the 2x times 3 to the 1. Remember that. So this is technically 3 lots of x squared minus 15 lots of 3x plus 44. Okay? This is the same as saying 3y squared minus 15y plus 44. Again, remember to put it back at the end. This is just, when you've got to change it. Yeah, I think that's everything on that chapter. God, I waffled then, but I think that it was all pretty good stuff. Okay, next chapter, chapter 4, probably one of the easiest chapters to get full marks on is binomial expansion. Okay, they give you the formula. You do not need to remember the formula. What you do need to remember is whatever the power is, for example, 7, remember it starts at 0. I don't know why some people do it 1, not sure. Then also remember that you need to write it out. Show your working, okay? If, and again, this comes up very rarely, but it's just something to take note. If they don't tell you what the power is, okay, remember this formula, the factorial formula, okay? They do not give you this, and sometimes it's handy to know. So, also, if there's like, let's say 2 plus kx to the power of 3. Remember, each time you've got to do the square the k or etc. If it then said, right, once you've expanded that, you're now going to multiply this by 3 plus, 4k to the minus 1. And it says, to the power of 4, whatever. And it says to you, the coefficient of x squared. Okay? Remember, how are you going to get a coefficient of x squared? There's, you can think logically here. The only way you can do that is this x cubed term times when this one become with the x to the minus 1, and because that's going to give me an x squared, or this x squared term times this number. So you don't have to sit there and expand everything out, just think logically. The last thing is as well, if it says find a solution of the square root of 40, the cubed root of 40, I nearly went into P4 then, the cubed root of 40, remember, that means 2 plus kx equals 40, okay? Inside the bracket of what we've worked out would equal 40 essentially, and we've got to manipulate this to help us. So, we'd say that kx equals 38 and then etc. And then we could substitute into our expansion. With your expansion, do not write commas, by the way. I've seen this before. I don't know what's going on. Depending whether it's positive or negative, you're going to have a number, plus or minus, a number, plus or minus, a number, plus or minus, etc. Okay, next up we have sum, sequences, geometric, etc. All the formulas are given to you. Always read the question. If we're adding by a certain amount each time, make sure you write A for arithmetic. And if you know you're multiplying by ratio each time, make sure you write G for geometric, okay? A lot of these is manipulation, and I suggest you write down what you know and what you don't know. You write down what your A is, you write down what your D is, you write down what your N is, and you go from there. Sometimes they overcomplicate, people overcomplicate things. If it says like the second term is something and the fifth term is something, literally do this. This is your second term. This is your fifth term. It's actually easier to see, like if it's plus D, plus D, plus D. Do you know? People always forget as well that you can make simultaneous equations. If it gives you 3 terms, and let's say this is geometric, this is times R, this is times R. So technically, if I called this A, B, C, you know that B divided by A is R. That's the same as C divided by B. Here you have a set of equations. Sequences is all about making equations, okay? You've got to make the equations with the information you're given, all right? Remember, sum to infinity, your R value has to be in between 1 and -1, okay? Then, just so you know, a sequence, you may or may not need this, is increasing. Okay, if un plus 1 is greater than un, and it's decreasing if un plus 1 is less than un, okay? Then something that people struggle with, and I don't know why they struggle with this, it's literally substitution. Okay, this is saying the summation of, let's have, log A to the B, okay? If I put B here equals 2, and then at the top I have 5, that means I'm going to substitute in, I'm going to find the sum. What does this mean? Sum means I'm adding. So all I do now is substitute in, and I follow the rules. This is my starting point. I start when B equals 2, I stop when B equals 5, and I go up in 1 each time. So how does this look? They didn't tell us anything about a, so I leave a as is. So this is log a 2 plus log a 3 plus log a 4 plus log a 5, etc. I literally follow the rule. Okay, you have a summation button as well on your calculator, which you can use to double check. Recurrence relations, whenever you say like un equals 3, and then it says un plus 1 equals, I don't know, and then you have like your un minus 4 squared, etc. Literally just press 3 equals, and then you're going to put this in your calculator, you put ants here. Okay, you'll know what I mean. Again, if you're not really sure, just quickly look at the other video. So that's sequences done. Oh, one more thing, sorry. If it ever says find the minimum number of years or maximum number of years or what is n, etc., remember, n has to be a whole number, okay? And if you get like 28.4, it doesn't mean round up or down. When in doubt, stick it in the calculator. Try 28, try 29 and see which one makes sense, okay? Oh, and one thing, be really careful. Sometimes the wording of these have really got people lately. If they say end of day, okay, what does that mean in terms of context? And also with the summation, by the way, if they say how many is this, between 2 and 5 is not 3, okay? Remember, that's 2, 3, 4, 5. That's 4 terms you need. Watch out for that. Okay, trigonometry, my absolute favourite, okay? If you use cast... I actually made a video on this, like a quick one. So if you're really unsure, this is what you need to do. And you need to remember some different things. What do you need to remember? Silly cow. Okay, that is tan equals sine of a cos. You're not given this. And you also need to remember that sine squared plus cos squared equals 1. You can rearrange these, manipulate these however you want, okay? When you are solving trig equations, you know, if you see a cos squared, manipulate. Literally, it's manipulate, manipulate, manipulate. That's all we're ever doing, really. And if you don't like using cast, draw sine, okay, and go from there. Now, changing intervals. If they tell you it's between 0, theta, and 360, but your interval you've been given is... they tell you, tan of 2 theta equals, well, you need to change your interval. That's your step 1. Change the interval, 2 theta then. What have you done? You've times this by 2, so you've got to times everything else by 2, okay? So this is 0, this is 720. If you see degrees, first thing you've got to do is put your calculator in degrees. If you see radians, you need to put your calculator in radians, okay? That should be your first point of call. Now, remember, if you are using cast, draw the opposites. Your calculator will give you the answer. If you have, you know, like, I don't know, you expand a bracket and you have like sine theta minus 2, and then you're going to have sine of theta plus a half, right, equals 0. And let's say there was a sine on the outside. Now watch out for this. This one on the outside means that sine theta equals 0. This one means sine theta equals 2, and this one means sine theta equals negative a half, right? This could happen with sine, cos, or tan. This is going to give you an answer. We're going to reject this because sine clone will be between 1 and minus 1, and this is going to give you an answer. This will also give you error on your calculator. Then make sure you go back and you read the question. They're trying to get you out, okay? But watch out for all of this. The more questions you do of trig, the more you'll be able to spot which one to, substitute quickly. Okay, differentiation. Now, this is lovely because what we're doing here is we differentiate twice and we find a stationary point. So to find a stationary point, when we differentiate, a stationary point is when we differentiate it if we put that equal to 0. This will give us a stationary point or a point on inflection, right? Then, how do we know if this stationary point is a minimum or maximum? When we differentiate again, okay, and whatever we found for x here, when we substitute that into our differentiation, if this is greater than 0, we have a minimum. If it's less than 0, we have a maximum, okay? And if it equals 0, it could be a minimum, a maximum, or that point of inflection. We don't know. So when that happens, when it equals 0, draw the graph. You know, have you done it where like you do what is if it equals 0, let's say our x value for this was 4, Okay, put 4 in here, then do 1 below, 1 above. Substitute it in to find what the gradient is, and what you find is sometimes you get this shape. What is that? That is a maximum. Sometimes you'll get this shape. And how do you know what shape, by the way? This is a positive gradient. You know positive gradient looks this way. This is 0. 0 means your gradient looks like this. And this is negative, okay? So you can substitute this in to your dy by dx to see what the gradient is about this point. You know it's a point of inflection if it, for example, went like positive, 0, positive, because that is a point of inflection. Just something to be aware of. I haven't really seen it often, but that's, it's always good to know. They always ask you sometimes to do modelling questions. They're like, the surface area and the volume. Just make sure you know some of these. Volume of a cylinder. Okay, that is pi r squared times height. Surface area of a cylinder. Okay, now remember, you've got 2 pi r squared. Why? Because you've got the lid at the bottom of the top. And then the curved surface area, 2 pi r squared, is the circumference, which is 2 pi r, times the height. If it asks you to model anything or show that again, manipulation. That's all it is, and just show it and rearrange. And if you have a h, but they say the volume is, x over 192, you see this type of question, there's no h here. So you've got to rearrange this to give h equals and substitute it into here, okay? And then work it out from there. Okay, last but not least is integration. Integration is so easy. This chapter is kind of split into two, right? So we have the integration and we're given numbers, between 4 and 2, and you're given an expression. Make sure you integrate it and then you put it in between. You put 4 in minus 2, okay? And you can also put the whole thing into your calculator to double check it, but you need to show all of your working or you're not going to get the solution. This is the one time I will tell you do not have to write plus c, okay? So you don't have to worry about your constant of integration. Then you have below or under the curve, etc. Make sure, if you're not sure, draw it out, okay? So remember, this is going to give you a positive gradient. This is a positive area. This is going to give you a negative area, but it's still an area. So make sure you watch out for that. And you can split it up between 3 and 0, and then 0 and minus 2. So I would integrate between 3 and 0. And then remember, I'm going to add the integral between 0 and minus 2. But if this gives me a negative area, I need to change it positive, okay? Then sometimes they give you find between, we have something like this where we have, that was terrible. Here we go. And then you have that line. So you can do this a few different ways. You can find the integral under the whole curve between here and this point x, and you can take away this triangle if you want, okay? Or what you can do is you can use not the formula essentially, but you can say, okay, well actually I want the integration of the integration of the curve minus the area under the straight line. That will also give you the same, okay? So you can do what you like there. Then lastly, trapezium rule. So remember, if you're given a table and you've got to find some values, just substitute in, nice and easy. If this is 0.5, this is 0.75, this is 1, this is your height, by the way, okay? So you're given the formula, x plus 2 is 1.25, let's say 1.5, okay? And you're given this, but remember, check your calculator, okay? It's this multiplied by the two ends, okay? Plus 2 lots of the middle, all right? Nice and simple. You have to write this out to get the marks. You don't write it out, you are going to be in trouble. Now, sometimes, let's say, when you integrate this, you put it into the trapezium formula, and it's 4, okay? And remember, this is f of x, right? Now, if you think about this, this is just a transformation. So sometimes, if they say f of x minus 2, well, actually, what's happened to our graph? We've just shifted it to the right 2. But if this was our graph, here, okay, and we shifted it to the right 2, so it's now here, did our area change? No, so our area is still 4, okay? However, 2 lots of f of x minus 2, what's happened here? My y has stretched, so technically our graph's going to look like this now. Has our area changed? Yes, it's got double. So this is going to be 2 lots of the integral, forget about that bit, of f of x, which is actually 2 times 4. Okay, this is, again, all about manipulation, and it's to do with a bit about being clever. Sometimes they like it when they have the log one and they have log 10 of something, I don't know, x and minus 4. If they have that and you've done this, remember this is the same as the integral of log 10 x minus the integral of 4. So integrate 4, you get 4x, and do it between the same limits, whatever it is. Well, I think that's everything. Whew, I feel like I haven't taken a breath. Good luck for your exam.